Acha, we have learned till here. Acha, I was making you solve questions. This question we have solved, this question we have solved. Let me give you one more question. Then we'll move to the next concept. Try solving this question. This one.
So what is apex of isosceles triangle?
Apex of isosceles triangle meaning? Wait. Two rods. Ah, see, it is like this. Apex means the pointed portion. Arey, what is this pen? See, like this it is. If I draw the triangle in this way, now this is our triangle, and your knife edge is here. It is supported at here, and this is your apex. Understood? The length, this length is L2, this length is also L2, this length whole is L1. So this will be L1 by 2, and this also will be L1 by 2. This is your knife edge.
Actually, it could have been like the opposite of the dragon.
It could be the opposite.
Like the apex could be at the top.
No, how how it is possible?
Like when it's supported on the knife edge, it's
It's see, it is given now. The arrangement is supported on the knife edge at the midpoint of L1, which is horizontal. How can it be? Achha, you are saying, sir, it will be like this. This way.
yes.
You can draw like this. If you want, if you want, you can do it also this way. Not a problem. This way also, this is L2, this is L2, this will be L1. L1 by 2, L1 by 2. You can take like this also. Since here we are believing that it's in equilibrium. You can think both ways. Both ways you can think, and in each way, when you'll get solve and get the answer, you'll get the same answer. Not a problem. What happened? You're not getting idea. Hmm?
No, sir. Like 1 minute.
How to do it? Huh? Hmm.
I'll try.
See,
I'll try another method 1 minute.
see, let me give you the concept how you will be thinking to solve it. They have given the apex of isosceles triangle is to remain at constant difference from the distance from the knife edge. Means what they are saying, if suppose I have given this distance as x naught, then when I have raised the temperature, after raising the temperature also the distance between this apex and the knife edge will remain the same. Means when the system has become like this, L1 dash, which is L1 into 1 plus alpha 1 delta t. What is this? And these two become L2 dash and L2 dash, where L2 dash is equal to L2 into 1 plus alpha 2 delta t. Okay, in that case also, the distance between this and the apex is same only. This is, they are going to say, they are actually saying this one. Now our task is to find, see, in the initial condition, when this was L1 by 2, the distance, this distance was L1 by 2 and this distance was L2. Can I say this x naught square is equal to L2 square minus L1 square by 4, right? Easy application of Pythagoras theorem. Height
Yes.
plus height square plus base square is equal to hypotenuse square. The other thing is, for this one, for this new case, when the length has increased, in this particular case, if we try to calculate this x naught square will be equal to L2 dash square minus L1 dash square by 4, which is L2 square into 1 plus alpha 2 delta t whole square minus 1 by 4 into
So you'll
L1
get
square
option B.
1 plus alpha 1 delta t. Which option? B.
Second
No,
option.
no, they are saying it is D.
2 root alphas.
Alpha 2 by alpha 1. 2 root alpha 2 by alpha 1 they are saying. Now because 1 and 2 are same, let me check. L2 square minus L1 square by 4 is equal to, I think they're using approximation or what? I don't think so. L2 square plus L2 square alpha 2 square delta t square plus 2
So
L2
you'll
square.
get option D.
Option D na? Correct. Minus L1 square by 4 minus L1 square by 4 alpha 1 square delta t square. They're using approximation, Haripriya.
No, sir. You'll simplify it, you'll get it.
Simplify one. Hmm. This is over. Delta t. Why my delta t is not getting? No, 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 no. No, no. No, Haripriya. We have to approximate it. Otherwise, delta t will remain.
No, sir. I did it as originally it will be just L2 square minus L1 square by 4.
Hmm.
I equated it is equal to the length after the change in temperature.
Hmm.
Actually, you'll get it, sir. You have to move the set with L1 delta t into right hand side, you'll get it.
But I'm not getting na. See what is wrong in my equation. Because what I am getting na, I am getting delta t here, delta t here. Here delta t is square. So anyway, if I cancel, try to take common delta t, one delta t will remain. And delta t should not be there in the answer. So what they are expecting means they are expecting us
Alpha
to
square is equal to 0. Yes.
delta t square is equal to 0.
I
They
did that.
want us.
Took alpha
Because
square is equal to.
because alpha is very small, na? That approximation you have to use. Then you'll get the answer. 2L2 square alpha 2 delta t is equal to 2L1 square by 4 alpha 1 delta t. Alpha 1 delta t you can cancel out. 2 will also cancel. You'll get what they are asking. L1 by L2 na. So L1 by L2 4 alpha 2 by alpha 1. So L1 by L2 is equal to 2 root alpha 2 by alpha 1. Simple. It was not complicated. Acha, see. Now I'll give you a question in which you'll be using this temperature concept rise in the length with the angular momentum, means mixed with the rotation. And this is a very common type of question that they usually ask. See this one. Kanishka, what about you? You are having doubt or not? It's okay, na? Everything fine?
Yes, sir.
Okay, okay, okay. Because you are not saying something, I thought you're having doubt or not. Okay. Hmm.
Sir, how do you find out omega in this?
See, what is actually happening? A uniform solid brass sphere is rotating with angular speed omega about its diameter. Its temperature is increased. So when we are increasing temperature, what difference it is making? The increase in temperature, what difference it is creating is the radius of the sphere gets increased. Initially it was like this. Initially it was suppose we say it was r1. Now the radius has increased to r1 dash. And that r1 dash is equal to r1 into 1 plus alpha 1 alpha delta d. Okay. Since it is solid sphere, its moment of inertia will be 2 by 5 mr square. For hollow it was 2 by 3 mr square. So what is happening when it is rotating with this angular velocity omega naught? Now it will be rotating with the angular speed omega 1. Why? Because its moment of inertia has changed because of the change in radius. Understood? Now, because since there is no external torque acting on the system, the angular momentum will be conserved. I1 omega naught will be equal to I2 omega 1. I2 is the moment of inertia in this case, I1 is the moment of inertia in this case. I1 is equal to 2 by 5 m r1 square. I2 is equal to 2 by 5 m r1 dash square. Okay. We have to do the calculation actually here. I'll approximate 2 into 2 into 10 power minus 5 into 100. One point 004. This will be 0.996 omega naught. Understood, Haripriya? Kanishka?
Yes.
Hmm.
Yes, sir.
Hmm. Now see, now let's move on to the next concept. These kinds of question actually they ask in this one on the basis of this rise in temperature and all. Now the other type of question that they ask is from calorimetry. Calorimetry, that was also a part of calorimetry only, but now I'll be teaching you about specific heat capacity and all. See, what is specific heat capacity? Heat capacity, actually, we should start with the heading. First, what is heat capacity? Heat capacity is represented by as it is delta Q by delta T. Unit is Joule Kelvin inverse. Means actually why we use this term, actually whenever there is a body its temperature is being raised or it is losing the temperature T1 to T2, when T1 is greater than T2, then what we say, actually the body loses heat Q, and the heat that it loses is given by, or if T1 was less than T2, in that case the same amount of heat would be gained. The amount of heat lost or gained is given by S delta T, heat capacity into T1 minus T2. That's the formula. That's actually the concept for finding out the heat loss, the heat gained by a mass. There, this heat capacity constant is used. What they found, actually, the heat lost or heat gained is actually proportional to the change in temperature they have found. And that proportionality constant was heat capacity. Now, the second concept is specific heat capacity. This small s. Specific heat capacity means heat capacity divided by mass m. This one. But remember, it is small s. But usually when we use in concept now, we use molar heat capacity. And you know what is number of moles? It is mass divided by molar mass. Okay. So why we learn actually these things? Why we learn actually these things? Because these formulas are being used to find out the heat actually lost or heat gained by a system of mass, by a mass which is in kg. So the important concept is whenever there is a mass small m whose temperature is being raised from T1 to T2, or when T1 is greater than T2, I said earlier, the amount of heat it lost, this Q, is given by ms1 into T1 minus T2. This is the concept, where S1 is the heat capacity, specific heat capacity. Correct? Understood? If the temperature, if this is heat lost, if T1 was less than T2, then same amount of heat would be gained. Okay, understood? This is actually important one. This concept is actually important. Let me give you questions to solve. Try solving this one.
One is to
1 is to 1. Correct. Very quick. What about you, Karisha? You got the answer? You want me to solve? See, let me explain you for Kanishka. Two liquids A and B are at this temperature. This is liquid A and this is liquid B. This is at 32 degrees Celsius and this is at 24 degrees Celsius. The mass is same. When they are mixed, the temperature of the mixture is found to be 28 degrees Celsius. So what happened? This A has decreased its temperature from A to this 32 to 28. So some amount of heat would be lost. And and the B temperature has increased. So the equal amount of heat it should have gained, because the temperature gain, the heat when it is mixed, the temperature heat is not lost from the system. So the amount of heat which is lost by A, actually it has to be gained by B. That's the actual concept. So we can say M T1, for this is for A, into 32 minus 28 is equal to MC2 into 28 minus 24. M into 4, C2 into 4. So C1 by C2 is equal to 1 by 1. C1 is to C2 is equal to 1 is to 1. This is how we do it. Acha, one easy question I'll give you. It's from the LCRT, but sometimes students find it difficult to solve. Try doing it.
So what is the specific heat capacity of copper?
It is not given in the question. They should have given it. Wait. Let me give you the. It is 4.18 into 10 power 3. Copper also they should have given, no? It's not given here. Wait. Let me write it. The specific heat capacity of water, it will be 4.18 into 10 power 3, and for copper it should be 0.386 into 10 power 3. This value they should have given.
Then have you given in kilojoule or joule? The
It's in joule only.
then I got 9.1 into 10 to the power 3 joules.
Hmm. Actually, they have said the answer is 9.908 kilojoule. Sorry, 908 joule kg inverse Kelvin inverse. The answer is 908 joule kg inverse Kelvin inverse. Hmm. Are you getting the same one? Because you are getting something like 0.91, na?
Mm.
But it's in what?
No, sir, I got 9.1 into 10 to the power 3. I missed a decimal place.
Hmm. Why? What about you, Kanishka? See,
I'm solving.
see what is happening. What is happening now? Sphere of 0.047 kg of aluminum is placed for sufficient time in a vessel containing boiling water. Means what? Its initial temperature, the boiling water, aluminium, when it was placed, so its temperature initially was 100 degrees Celsius because it was in boiling water. Its mass is 0.047. It is then immediately transferred to 0.14 kg copper calorimeter containing 0.25 kg at 25 degrees Celsius. Now this aluminium is actually placed in water, 0.25 kg water at 23 degrees Celsius. So it will lose some water, lose some temperature. Ah. No, not 23 degrees Celsius. It was 20 degrees Celsius. Water was at 20 degrees Celsius. The temperature of water rises and attains a steady state at 23 degrees Celsius. Hmm. Copper, this is 0.14 kg. This is copper. Specific heat is given. Copper is not given. No? Water was at 20 degrees Celsius, means the copper would also be 20 degrees Celsius only. So this copper has been raised from 20 to 23 degrees Celsius. Water also raised from 20 to 23 degrees Celsius. And the aluminium has decreased from 100 to 23 degrees Celsius. So the equation would be the heat lost by this system is actually equal to the heat gained by this system, Q2 plus Q3. This Q1 is equal to Q2 plus Q3. Q1 is M aluminium into C aluminium into 100 minus 23 is equal to M water into C water into 23 minus 20 plus M copper into C copper into 23 minus 20. That's the equation you have to write. Now what is given to us? This is 0.047. C aluminum we have to find. This is 100 minus 23, which is 77. Water is 0.25 kg. The C of water I have written. S of water is 4.18 into 10 power 3 into 3 plus mass of copper is 0.14 into the copper specific heat is 0.386 into 10 power 3 to 3. This equation you have to solve. So when you will solve this equation, you will be getting that answer that we are getting, that I have written. Now you try to find, Haripriya, where you have done the mistake. Did you do like this?
Yes, like I must the 10 to the power 3 have converted it, but I've kept 10 to the power 3 as 10 to the power 6.
Silly mistake. But anyway, you have understood the concept. What about you, Kanishka? You have understood the concept?
Yes, sir.
The answer you'll get is 908 or 0.908 kilojoule. Kilojoule, kg inverse, Kelvin inverse. This should be your answer. In the next class, I'll teach you about the phase change, heat transfer in phase change, and then the actual heat transfer part. That is interesting one. Conduction, convection, and radiation. That part will start. Next part is only theoretical. The few part is theoretical. Heat transfer in phase change, latent heat, and all we'll discuss. Okay, let's end it then. Bye bye.